Okay, so hi. In order to decrypt the message that Alung was supposed to give to Bosu is to find the inverse of each K1, K2 and K3 and then multiply the inverse with matrix P. So we were given specific task to find the inverse of K1 using the adjoint method, which we will find the determinant and minus and cofactors of the K1. So I choose to find the determinant first. What you have to do is by closing the choose any row which is first, second, third or fourth row, but I choose the first row. And what you have to do next is by closing the first column first row, second column first row, third column first row and the fourth column first row, and this is what you will get when you close down the rows and columns. So in order to make it easier, we solve it by one. So in order to not get confused, so the same thing we did right here by closing down the first column first row, second column first row, third column first row. And it is basically what you got after doing that. So we're not done yet, so we have to we have to sum up all together the result that we get, which is 5 multiplied by 20 minus 3 multiplied by 5 plus 4 multiplied by negative 22 and minus 3 multiplied by negative 10, and you will find the determinant of K1 is 27. So we will continue by finding the minus and cofactors of K1. So what I did was basically the same, like find the determinant, except when you are calculating the minus and cofactor, you have to closing one by one, to close down first each column and each row. So this is what I get. This is what I got. So this is by closing down the first row, first column, first row, second column, first row, third column, first row, fourth column. So this continue by second row, first column, second row, second column, second row, third column, second row, fourth column, and so on. So like we did before, in order to make it easier, we solve it one by one, and this is what we got. Like that. So you after we finish with what we calculated, we have to transpose the matrix that we got by interchange the rows and column. So we got 20, negative 7, negative 14, 5, negative 5, negative 5, 17, 8, negative 8, negative 22, 5, 10, 8, 10, 10, negative 7, negative 11. So when we interchange the rows and columns, we will get 20, negative 5. Basically what I did is like the first column will be the first row when we transpose the matrix. So and continue, second column will be the second row, third column will be third row, fourth column will be the fourth row, so on. So we got after we transpose the matrix, we got 20, negative 5, negative 22, 10, negative 7, negative 5, 5, 10, negative 14, 17, 10, negative 7, 5, negative 8, 8, negative 11. So to find the inverse K1, we have to multiply the determinant and the minus and cofactor. So we will get this as a result of inverse K1, and then in order to find the message that Alung sent to Busu, we have to multiply with matrix P. This is matrix P, this is the inverse of K1, so we will get this as the result. So the message cannot, we conclude that the message cannot be decrypted because the inverse has negative integer, which is not included in the reference Alung sent to Busu. So negative is not in the reference, also there's no fraction in the reference also, so there's no message behind it.
We are trying to break down the K2 matrices by using ERO, elementary row operation. There are three procedures for elementary row operation ERO, such as the first one, interchange any two rows. Second, multiply a row by a non-zero scalar, and the third one, replace a row by the sum of itself and a multiple of another row. So for the first trial, we change the K2 matrices into an identity matrix, As we can see, for the last step and the third row of the matrices change completely into the zero data, which means that inverse of K2 matrix does not exist. Then we start over to find the inverse of K2 by using ERO. Same thing happened for the last step. At the last row, all the data change completely into 0, which means that the K2 does not has an inverse. To prove that K2 does not has an inverse, we calculate the determinant of this matrix. As you can see, when we calculating all the determinant of this matrix, the result of the calculation becomes 0. When 1 over determinant, which is 1 over 0, is undefined, therefore K2 does not has an inverse.
This time we will be discussed on the third question. The question sounds like, find the inverse of K3 using either methods, and I will use the adjoint method for this question and describe the message using the inverse. Is it the correct message? If the answer is no, then I explain why not. Okay, so here we have the matrix 4 by 4 of K3. So like I said, I want to use the adjoint method. So what should I do? First, if I were to use the adjoint method, I need to find the determinant. And to find the determinant, you have in this step, I will choose this row, the first row. So in order to find the determinant, I'll have to take these 3 and put it in front, and then I will close this column and this row, and it will left us with 5, 4, 2, 1, 2, 4, 4, 2, 5, and we will key in the matrix here, and then minus 2, because this is positive, negative, positive, and negative. So minus 2, we will close this column and this row, and we will left with 2, 4, 2, 4, 2, 4, 2, 2, 5. And then plus with positive plus 2, then we close this, and we will be left by 2, 5, 2, 4, 1, 4, 2, 4, 5. And the last one is negative 3, 2, 5, 4, 4, 1, 2, 2, 4, 2. Okay. How do you want to solve this? In order to solve this, you have to do another one like this, right? Because if you have this, then you can easily do it, because when you close this and you close this, it is as if you have A, B, C, D, and you can just solve it like normal, which is 2 times 5 minus 2 times 4. So first, we will have to close this. We'll have to take 5, and then close this column and close this row, and then we're left to 2 times 5 is 10, 4 times 2 is 8, and then negative 4. You close this, and then you're left with 1 times 5 is 5, negative 4 times 4 is 16, and then the last one is positive 2. Close this and close this, you're left with 1 times 2 is 2, and then 4 times 2 is 8. So then you can easily solve it, and you'll get 42. You'll do the same step for the rest of this, and then you'll get the answer. Once you get the answer, you can just substitute it in this matrix like this, and then after you have solved this part as well, you'll get the determinant. All right, next, we know that this matrix 4 by 4 is equal to this cofactors. No, it's not equal, but here I put it here to tell you that this is C11, C12, C13, C14 is not equal. But I just want to tell you what is this, what is this, what is this. Okay, why do I want to tell you this? Because the next step of finding the inverse of K3, we need to find the transpose of cofactor. So we have to find the cofactor first. How do we find the cofactor? It is the same way as we did on the adjoint method. Okay, on the determinant, or how we find the determinant. But the difference is here we will put the positive, negative, and negative, just in case, so that you won't forget it, because this is positive, negative, negative, positive, negative, positive, negative, negative, positive. So in case it is mandatory for you to put the sign, right? So you'll just do it like as usual, and you got this. And then just to be safe, I will substitute it. Then the first row, I've already got the first row, which is 42, 36, negative 54, and negative 24. Coming up next, we will search for the second and third row. Same method will be used, and once you've got all of the answer, just substitute it, and you will get 3 rows. Okay, next we will find the fourth row, and you get a complete cofactor matrix. Once you've got the complete cofactor matrix, we don't want this cofactor matrix. We want the transpose of this cofactor matrix. So how do we find the transpose? In order to find the transpose cofactor, you have to do it like this. This row will be the column. This row will be the second column. This third row will be the third column, and the fourth row will be the fourth column. And we will be left with these. All right, next. Now we can find the inverse of the K3. In order to find the inverse of the K3, you have to use this formula, which is 1 over determinant A times by the cofactor, the transpose cofactor. Okay, this you'll just have to multiply it. 42 multiplied by 18, 36 multiplied by 18, negative 54 multiplied by 18, and so on. Once you finish this step, you will get this matrix. All right. So we've already got the inverse. In order to describe the message, you have to times it to times this with the P matrix. The P matrix will given. Oh, sorry, I'll drag it here. The P matrix will be given like this: 72, 162, 108, 126, 144, 177, 158, 156, 115, 181, 136, 154, 128, 133, 94, 206. Okay, this is the P matrix. All right, so in order to describe the message, you have to multiply each of these with this. So how do you multiply it? If it is this, like this, it is just simple. You just have to times it like this, like this, like this, like this. But this is a 4 by 4 and 4 by 4. How do you multiply it? Okay. If you want to look for the C1Y, to this point, this first point, what you have to do is that you have to find the sum of this column, of this row and this column. All right, so what you have to do is 72 times by 7 over 3 plus 162 times by 2 plus 108 times by negative 3 plus 126 times by negative 4 over 3. Then how do you find this root? This particular spot? You have to do it like this. 72 times by negative 4 over 9 plus 162 times by negative 1 over 3 plus 108 times by 5 over 6 and 126 plus 126 multiplied by 1 over 9. Then how about this part? For this part, you have to do it just like this part. But the difference is you'll use this entire row and with the same column. So it will be like 144 times by 7 over 3 plus 177 times by negative 1 over times by 2, 100 plus 158 times by negative 3, and plus 156 times by negative 4 over 3. Okay, once you have find all of these, once you have do all of those steps that I just told you, you will be left with these. Now, let's try and describe the message. Okay, so this is what the question have gave us. Now, I wonder what the message is. Can we get the message now? Let's see. 0 is A. You'll just have to substitute it. And yeah, there we go. We've got the message now. So, okay, that's all from me. Thank you for listening.
Matrices
Tapi bohong.